This is ENG8314, just a little lesson on how to plot in Excel. So here I've just set up an Excel sheet with a cell for mass, spring stiffness, got initial conditions. What I'm going to start off with is in lab 4, question 1. Our omega n would be equal to the k divided by the mass to the exponent 0.5. And for those who aren't familiar with the exponent in Excel, you just use the hat, brackets around the values, and then you should get the angular natural frequency. So we know that f is equal to omega n. So I'm going to click that cell. Just go back. I'm going to say hit equals this divided by 2 divided by, in Excel we have a function pi, and so this should give us the frequency, and then we know that frequency is period is 1 over f, or 1 over frequency. So you can see our period is about 0.4 seconds. So in order to show, let's say, 2 cycles with good granularity, let's do our first point at 0.05. So that should be about, actually let's try 0.05. So if I do 0 and then 0.05, I can now drag this and it will just copy that pattern. So let's go up to 2 seconds here. Okay, so we have 2 seconds. Just going to expand these columns here, and then I'm going to center them. So you can see here, I just have x at t, it's going to be this cell here, dx at t, which is velocity, and then ddx at t, which would be acceleration. So I'm going to enter my initial conditions here, which is 0.1 x naught, and then 5 meters per second for x dot naught. So we know from simple harmonic motion that displacement is equal to x naught. Now, in order, this is a constant value throughout the calculation, so if I hit F4, I put dollar signs around it, and that prevents it from incrementing when I copy it to row 14. Something important when working in Excel. So now it's going to be cos omega n, so I'm going to click on omega n, and again, I don't want this one to increment as I start to drag the formula down, so I'm going to hit F4. And that's going to be times my t value, which here is A13. I'll type A13. Now I do want that to increment in the numerically, but I don't want to increment. Actually, let's just leave it at that. So then I have cos, and then we know it's plus x dot naught, and I don't want that to increment, so I hit F4, divided by omega n. And again, I don't want that to increment, so I hit F4. And now this is times sine omega nt, right? So I'm going to hit omega n, I'm going to hit F4, and then times my A13 for time. So you can see now that this should come out to x naught. Now, recall that I put in these dollar signs to keep the values from incrementing as I drag the formula down. So let's just see when I go to the next one that I'm still on B5, I'm still on B8 for omega n, which makes sense. I'm still on B6, and I'm still on B8 for omega n. So that formula appears, at least initially, to be incrementing properly. So let's just copy that down. I double click there, it's going to go all the way down to the bottom. And you can, if I go down to the bottom here, I can see that that formula is input the 2 seconds. And it's held all the values up here, so 0.1, 5 meters per second, x dot naught, omega n. So that formula appears to have copied down correctly. Now moving on to velocity, we know that velocity is equal to the first derivative of displacement. So that's going to be negative omega n, let's scroll up here, times, now hold on a second here. I don't want omega n to increment, right? So I hit F4, which is going to add the $ brackets, which prevents it from incrementing, the cell from incrementing as I copy the formula. Then I'm going to multiply by x0, and again, that's another value I don't want to increment. And then I'm going to do times, this time sine omega n, another value I don't want to increment, and then I'm going to times it by this here. And I do want that one to increment, so I'm going to leave it. And then I'm going to do, this is plus x dot naught. Now I don't want that to increment. And this one's going to be times cos omega n, which I don't want to increment, so I hit F4, times A13, A13, which is a time at 0. And that should give me my velocity. And there it is, x dot naught, which is this value here, which makes sense because the sine term up here goes to 0 at time equals 0, and the cos term turns to 1. So if I just double click right here, that formula gets copied down. So now the last formula is going to be acceleration. So again, we had equal sign, so this is going to be negative omega n, a value I don't want to increment, so I hit F4, times, actually that's squared, so I'm going to go bracket 2, sorry, squiggly hat 2, so that squares the omega naught, and I go times x naught, a value I don't want to increment, times cos omega n, a value I don't want to increment, times A13, which is this cell right here. And I do want that value to increment, so I don't touch it. I don't hit F4, basically. So now it's going to be minus omega n, a value I don't want to increment, it's a constant, times x dot naught, this one right here, a value I don't want to increment as an initial condition, sine times sine omega n, a value I don't want to increment, so I hit F4, and times A13. So that should give us, and I feel like I'm missing a negative there. Does that make sense? Negative, negative. So my first question would be, why isn't this negative? Let's see here. Okay. I can only guess that for some reason this negative value here is being negated by this square term. So if I do negative 1 times, ah, there you go, negative 25. Okay, so Excel's being a bit tricky there when you put the negative term in front of a square, it's making it positive, which, okay, it's not really not order of operations, but anyway. So there we have our values. So now how do we plot these values? So let's do this here. I'm going to select them all. I'm going to go Insert. Let's try, yes, those values. That's it right there. So it's scatter with smooth lines and markers. So first thing I'm going to do is I'm just going to move this chart to its own page. I'm going to call this question 1, Q1. Okay, that's better. So you can even see with my granularity here, I've only got maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess about 9 points per cycle is enough. If I wanted to get a bit more granularity, I could go 0.025. And I could do this here. And if I copy it down, there you can see now I'm at 1 second, and I should show about 2 cycles. There you go. So the thing about this is this distance value is very, very small in comparison to the acceleration. This is our acceleration value. So I'm going to select it, format data series, and I'm going to move it to these. This is the primary axis over here. If you look over here, primary, secondary. So if I move it over here, I get a second axis. And now you can see my displacement is about the size of my acceleration on the same physical scale on the screen. But you can see I've got the secondary axis over here, and I've got a primary axis over here. So this is for acceleration and velocity, and this is for displacement. Let's see if we can add a legend. Let's add a legend on the right. There you go. And for chart title, it's already there. I'm just going to say Q1. And so there, you can see that we've got dx by dt, ddx by dt, and x at t all in one plot with the velocity or the displacement on this axis, and then the velocity acceleration on this axis. Now I'm going to add axis titles. So I'm going to say primary vertical. Yeah, there it is there. I'm going to say acceleration velocity. And then I'm going to say axis titles secondary vertical. I'm going to call this one displacement. And there you have a Q1 chart. And I will copy this up to Blackboard for everyone to review and help them with the lab.